Very interesting. I don't want to be caught in such a situation ever. All right, few other definitions of FMEA template which we have seen. Current control. How are you trying to control that? Are you having any preventive mechanism, right? How would you control that? For example, think about this. I have an iron box to iron the clothes. I want to iron the clothes and I have an iron box. And I forgot to switch it off. Do you think if I forget to switch it off, it's going to be heated to a temperature of 200 degrees or 300 degrees? Does that happen? No. Most of your iron box have this mechanism which automatically switches it off. It will automatically get switched off, right? If you keep it for a certain time, right? Or if it reaches a particular temperature, it automatically switches itself off. That is a preventive control. Do you have those kind of a control? And then comes severity, detection, and occurrence. But here is a risk priority number. And this is how you calculate it. Severity multiplied by occurrence multiplied by detection is going to give you a risk priority number. Based on this number, you're going to prioritize your risks. Let us look into the severity. How critical or serious a potential failure could be on your product or the process. If the failure is so serious that it can stop your production, it is graded as 10. And if it is not going to have a lot of impact on your project or process or product, then you grade it as 1. Then you have another category which we need to understand. Detection. Ability to detect the failures. How easy is it to detect the failure? If the potential failure is easy to detect, the grade should be low. 1. You rate a particular risk or an event or an activity or a function as 1 if it's extremely easy to detect. And you rate it as 10 if it is extremely difficult to detect. All the natural calamities, earthquakes, tsunamis, right? Wildfires in the forest all of a sudden. All these are very hard to detect. Hence, probably we give a rating of 10 when it comes to detection for those kind of events. Then comes occurrence. How often does this failure occur? The likelihood of an occurrence is expressed in a ranking of 1 to 10, 1 for rare occurrence. All your natural calamities, they might be extremely difficult to identify, and they are also very rare. 10 for often activities. How often does your wife shout at you? Very often. So you rate it as 10. Can you detect your wife shouting at you? Yes, almost always. So it's 1. Extremely easy, right? So jokes apart, 1 for rare event and 10 for most often occurring event. Here is the definition or the various definitions of the various ratings which we have. We have already discussed that if severity is given as 1, it has no effect, no discernible effect, or slight inconvenience caused to operator or to the operation process, or there's no effect absolutely, right? From there it moves on, and if I'm going to rate something as 10, it is hazardous without warning. It might endanger the operator, machine, or assembly without a warning. 9 means at least there is a warning. There is a warning symbol for me. So you can change this definition based on your process, based on your product, based on your industry, your sector, your client, and all that. But it is extremely recommended or highly recommended not to make changes to these top set. 10 and 9, try not to meddle with this, try not to make any changes to this. So you can use this as a quick reference in classifying or putting a number against each and every event. Then comes occurrence. How likely is an event to occur? 1 means failure is unlikely. How unlikely is it? Less than 0.01 per thousand machines. So there might be 1 failure in probably 100,000 or more entries, right? In CPK, we have already discussed this, right? CPK value would be greater than or equal to 1.67 if the occurrence is 1, right? What do you mean by CPK greater than or equal to 1.67? We have discussed in the measure phase also, right? My mean is closer to my target, right? If this is the dartboard and this is my bullseye, all the points might be falling somewhere here at and around this target. If this is the scenario, my CPK value will be greater than or equal to 1.67. So almost always I'm on target. That is what it means. Only 1 in 100,000 times I might miss my target. Moving on to 10, right? Very high. That means there are 1 in 10 errors which might occur. And CPK value significantly drops. That is another way of looking into occurrence. This is a reference for you guys. Then comes detection. How likely is it for me to detect something going wrong? If I'm putting as 1, that means design control will certainly detect a potential cause, right? And A means something is error proofed. I'll not let you make a mistake. All your electronic gadgets, right? Think about your USB port, right? It is error proofed. I cannot put my USB slot or I cannot put my USB device in my LAN slot. I cannot put in my VGA slot, HDMI slot, or power slot, right? Can I put my USB device in the power slot? Can I do that? No, it is error proofed. It will not even let me do that. If I'm using a gauge to detect something, if I'm using a thermometer to measure the temperature, that is your category B. C means I'm doing a manual inspection. If I'm doing a manual inspection, it is so much difficult for me to identify something, to detect something going wrong. If I'm using a gauge, so much. And if I'm using, or if I'm trying to error proof, it is extremely easy for me to identify something going wrong, right? 10 means absolutely certain of non-detection. You cannot detect it, or you have not checked it, or you're not going to check it, or you cannot check it. In that way, you rate the detection as well. And this is how we are going to calculate the risk priority number to prioritize my risks, right? Severity multiplied by occurrence multiplied by detection. If I have a failure mode, I need to know what is the effect it's going to have, what is causing me. Do I have any controls in place? I multiply all these three to get my risk priority number, based on which I'm going to prioritize my events and then come up with an action plan. This is what I do. Let us look into a quick case study. Reduction in risk priority numbers. I have severity, I have occurrence, and I have detection, right? I need to reduce, right? How can I do that? Severity. This number cannot usually be changed, right? Only if you change the design or process, only then probably I can reduce the severity ranking, right? Look into occurrence. Design process revisions or preventive controls can reduce occurrence rating. Detection, how can you reduce that? This number can be reduced by instituting a good detection technique, probably a good inspection process or a testing or a visual control will help me detect the problem easily. Here is a case study. Now, can you help me order the importance of addressing these process steps to reduce the overall risk? All have the same risk priority number. What are you going to prioritize first? Would it be A, B, or C, or D? Which one would you rank first? Right? First importance should be given to severity, right? You will say that severity 10 means it's going to have significant impact. It is going to be disastrous. And this disastrous event is going to occur 8 times, or it's going to occur most number of times, though it's rare to detect. This is how you prioritize. It's going to occur. Something which is going to be deadly is going to occur most often. So probably, if you ask me, I would rate B is #1 priority for me, followed by D because it has high severity. And then I would move on to A because A and B both have, A and C by the way, both have the same severity, but this is occurring most number of times. So probably I will say it will be B followed by D, followed by A and then C. This is the order in which I'm going to prioritize these events or risks. Okay,